The four basic stresses that are encountered by lumber are compression, tension, torsion, and shear. And you'll experience all of those forces throughout the house. Tension is when I pull on a member, and I'm pulling as hard as I can. That is tension, and this material has to resist that force or it's going to break. Compression is when I'm pushing on it. I'm pushing down in this direction. I'm loading the member from the top and squeezing it down. Shear is when I have a force pushing up and a force pushing down adjacent to my upward force. So I'm trying to cleave this in half. Think scissors. Scissors shear the material. You have one blade coming up and you have one blade right next to it coming down, and that shears the material. And then torsion is twisting. So if I take this here and I twist it back and forth, I'm applying a moment around it like this. That is torsion. Let's think about a house and how it resists the forces that it encounters every day. Compression, tension, torsion, and shear. And you'll experience all of those forces throughout the house. Let's take a house from the roof down and show how all of these forces are generated and how they resolve at the foundation. So starting at the roof peak, you have two pieces of material coming together with your rafters. And these rafters are being pulled down by gravity. They're supporting your roof on top, and gravity is pulling all of that down. It's also trying to push those walls away from each other. If you've got a peaked roof, the peak is pushing down and these walls are trying to get pushed apart from each other. So they're tied together with either a floor or with some sort of bracing or with a joist across the attic. And that holds these walls up while the roof is pushing down. So as the roof is pushing down, these rafters are in compression. It's pushing against the walls outward, and these joists are holding the walls from falling down. Those are in tension. So our compression is offset by our tension, and then that weight of the roof is translated down through our walls, again in compression, and the ground or the foundation is holding those walls up. On the floor, when I'm walking across there, I'm putting a downward pressure on the beam that is holding the floor up. And as this beam deflects, there is a compression in the top member and tension in the bottom member. I know that that's a little bit difficult to comprehend. It's like, how, if you're bending it, how's the top getting squeezed together and the bottom pulled apart? Well, this is our beam, right? I'm walking right here. As this beam deflects, you see how the top is going into compression. It's crinkling. So as I bend this, my bottom is staying tight in tension and my top is compressing, right? So I've got compression and I've got tension. And if I took this all the way to failure, then the bottom is going to rip up. We're going to actually rip that bottom piece up, or the top is going to crumple together.